Hello to my Math 186 students. This is your instructor, Mrs. Thomas. And I want to start on chapter 10 with your practice problems, which is on IV therapy. So I have quite a few practice problems. I want to go over at least, if you need to stop the video, I'm zooming in so that you will be able to see the practice problems I have. And this is just for students who oftentimes reach out to me and say, Ms. Thomas, do you have any practice problems that I can do? So let me go over at least 1 through 12 to give you a good understanding of IV therapy and what you need to divide and what the formula is. So let's go to our textbook. Okay, so the text is on chapter 10, which is IV therapy, intravenous therapy. The learning objective will be, I want you to explain the purpose of IV, whether it's fluids and medicine. Identify various infusion sets and tubing, whether it's a PC pump. I want you to be able to calculate infusion time in hours and minutes. Also, I want you to be able to calculate the flow rate. And all of this is in your text in milliliters per hour. The rate of infusion when we're thinking about an IV push. Calculate the flow in milliliters per hour for manual and electronic regulation. When the infusion is less than 1 hour, we will use, of course, 60 minutes. And also, we're going to calculate the drops per minute using the quick formula with a constant factor. I want you to be able to also describe the intermittent IV fluid therapy, whether it's an IV piggyback, IV PB, or it's going to be an IV push. I want you to know nursing technology, whether it's D5W, which stands for dextrose 5% water. And all of this information can be found in your textbook under key terms. The drip rate is also important when you're thinking about IV, as well as the drop factor. You have different flow rates, infusion times, and titration. I want you to know about just IV fluids in general. Okay, so here we have the sodium chloride injection. Okay. Here they have the commonly prescribed IV fluids. So you will know when you see NS, that stands for normal saline. D5W, 5% dextrose in water. So these are just terms that you will be using definitely in this course, but also in your medical dosage course. So it's just important to understand the IV, to understand infusion pumps, and what does that mean for you as a future nurse or in the health profession. We're going to look at the electronic fusion pump, how to calculate the infusion time in hours. So I want to make sure that you understand completely about the drop factor of IV. Be able to calculate the infusion time. And this is how we will calculate using the total volume, which is the milliliters that the doctor ordered. You're going to divide that by the milliliters per hour. And that will give us the number of hours that the IV is supposed to run. So they have various examples in your book, okay, which is called the standard formula, which is you just dividing the total volume divided by the total time, okay, which is going to give you the milliliters per hour. Okay, this is using the standard rule, dimensional analysis. When you just divide really the milliliters by the hours, it's called dimensional analysis when you do that. And then you will have like the standard form, okay, which I know a lot of students, when it comes to the IV part, they utilize more so the standard formula and dimensional analysis as opposed to doing the actual standard form. But I will show you both methods in dimensional analysis. All of this is covered in your text, the IV drip rate or drops per minute, and I'm going to show you how to do that. And when you see GTT, that means drips, okay? Some IVs will drip faster than others, and some IVs will drip slower. So this is the standard formula that we're going to also use in this text, which is the total volume times the drop factor, which is usually GTT, all right, the number of drops, divided by the total timer. And notice that it's in minutes, okay? So if they give you, for example, 8 hours, you're going to change that 8 hours to minutes to fit the formula. Okay, and this is our standard formula and my dimensional analysis here. Okay, students, let me get to the practice problems that we're going to do. This is actually your homework, page 210. This is actually your homework assignment. And I know you already probably have the text, but this is the actual assignment. Okay, so let's get started. Okay, for number 1.